Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can sketch graphs of polynomial functions when we're given the function and the solutions to the problem, or those zeros. So what we're going to do is we're just going to sketch a picture of the graph. Now, this is a sketch. It's not accurate by any means, other than we can figure out where those points are, where it crosses our x and y axis, and kind of decide if we're going to have maximums or minimums in certain locations, and where that increasing and decreasing kind of occurs. So we want to sketch a graph of this function with this equation here given the following solutions. So with our solutions, the very first thing we want to do is actually put a dot at each of those solutions. So we have one at 0, we have one at 3, and we have one at -5. Now remember, depending on the multiplicity of our zeros, that's going to tell us what our function is going to do. So if I have an odd number of multiplicities, then it's going to go through it. And if we have an even number, then what it's going to do is it's going to do what we call a bounce, which means that it's going to hit the line and then go the other way. So in this case, we only have an odd number of multiplicities, 1, 1, and 1 of each of those, right? We have 1, 0, 1, 3, and 1, -5, which means I'm going to go through each of those points there. Now the question is, where am I going to start? So as I start, what we're going to do is actually look at our first number there. Now, that very first coefficient will actually determine our end behavior as it becomes more positive. So if our first coefficient is negative, then our end behavior means that we're going to go negative on this end. If it's positive, we'll go positive. In this case where it's negative, what that means is our function is going to go up, come down, go down, and then come up. And we're going to look something like this. And this makes sense because we have three kind of changes: down, up, down, so we know that it's going to be a cubic function. So that's kind of a way that we can graph those. So let's take a look at another example here. Now in this case, we do have a multiplicity, so let's sketch this graph here. We have 1, -3, we have 2 zeros, and then we have 1, 5. So what that means is at -3, as we draw our points here, we've got a -3, a 0, and a 5. That means at -3 and at 5, we're going to go through it. But at 0 here, we're either going to bounce down like this, or we're going to bounce up, depending on what that end behavior is. So let's kind of decide what we're going to do here. Now, our end behavior, again, is always coming from this first term. So in this case where this is negative, that means that our end behavior on the right side is going to be negative. So we're going to start with that as negative and then use that to graph it. So we're going to come up, we're going to go down, but instead of going through this, we're actually going to bounce and then come back through. And again, this one makes sense because we have a degree of 4, which means it's quartic. It's going to go up, down, and with those 4 motions, we know that it's a quartic function. So that's kind of how it's going to work when we're sketching these graphs. Now let's take a look at one last one here. And so we are going to sketch our graph here. Now again, in a previous video, we talked about how we can actually find these solutions through factoring. And in this case, it factors really well. Sometimes we're not going to get something that factors as well, and that will be talked about in a future video. But for the sake of this video, we have both our solutions and that equation there. So let's go ahead and draw a dot at our solutions. Now notice we have a multiplicity of 2 3s and a multiplicity of 2 -3s. So I'm actually only going to draw a dot at 3 and -3, even though we have 4 numbers here. Then using this first term, we're going to decide what it's going to look like. So because that first term there is 1 and it's positive, that means my graph is actually going to go positive after it hits our last endpoint. So we're going to come down, but we have a multiplicity of 2, so we're going to bounce and then come up and then come down and bounce and then come back up. And that's what our function is going to look like. This is a rough sketch. Again, this 81 actually is our y-intercept. And so what that means is, if I can spell intercept, what that means is that this is actually going to cross way up here. So really our graph, if we're thinking about a more accurate look of it, we really have, if this is 81 up here where it crosses, we know that we actually really cross right here. So our graph looks like this. So kind of makes a W shape. It's going to be really thin. But again, we can check that this is right using that quartic function idea, where we know that this, and this, those 4 changes means that it's going to be a quartic function. So that's how we can sketch a graph given the solutions. So again, we can find these solutions by graphing. We can find these solutions by factoring, but we want to use them to factor and then sketch a graph. So if we're given those solutions, or sometimes they're called zeros, we can use them depending on their multiplicity to figure that out. And again, with our multiplicity, if we have an odd number, we're going to cut through. If we have an even number, we're going to bounce. So again, this one had some odd ones and some even ones. And the reason why we do that bouncing, in case you were wondering, is because what happens when we have a 2, if we have an odd number 1, it goes straight through. If we have a 2, what happens is it wants to go through, but then it also wants to come right back. But instead of like doing this weird loop thing, because remember it's a function, what it does is it just hits it. Similarly with the 3, it's going to go through, it's going to want to come back out, and then it's going to want to go back in. And so oftentimes when we have a multiplicity higher than 2, it'll go in, out, back in, and then back out. And so we end up getting these little pieces that look like there aren't any change. It looks like it gets flat because our function's trying to decide, am I going back up or am I going back down? I don't know. And so it's actually pretty cool how that multiplicity affects what our graph looks like. And it ends up turning into something like that. So please check out the next video in which we talk about how if we can't factor a polynomial, how we can find those solutions so then we can sketch a graph. If you have any questions, feel free to reach out, but that is how we can sketch a graph of a function based on the solutions.